morning, good afternoon, good evening, Sip&Talkers, and welcome back. I have just finished my third espresso, and I am ready to use cold, hard computation to crush all sentimentality today.
Wow. Okay. That is quite a mission statement for today's Sip and Talk.
I'm feeling it.
And it fits, because we are diving into something pretty heavy, but also, I think, profoundly insightful. We usually talk about how AI is going to reshape the 2026 economy.
Right, the practical stuff.
Practical stuff. But today we're talking about the essence of AI, what it fundamentally is, and how it might just help us unlock the universe's source code.
Yes, exactly. We're leaving quarterly reports behind and jumping straight into the geometry of space-time. And to kick this whole thing off, we have to drop this just ultimate provocation from Stephen Wolfram.
Oh, yeah.
He recently said something that sounds so arrogant, but, I mean, coming from him, you have to listen. He said, "No AI truly impresses me."
It's an incredible statement. I mean, you can't just dismiss that from a guy who published a physics paper at 15 and had a Caltech PhD by 20. He's earned the right to say it.
Yeah, for sure.
And his core belief is just fascinating. He thinks that large language models and, LLMs, they seem smart, not because they are smart, but because their architecture is just a clumsy imitation of the human brain.
Ouch. A clumsy imitation. That is a brutal take on the tech that's supposed to take all our jobs. So I guess that's our mission today, to decode Wolfram. Is AI this amazing key to fundamental truth, or is it just a really, really fast, mediocre parrot?
Let's start right there with that core conflict, imitation versus actual computation. Because Wolfram's critique of LLMs, it's all about how they really work under the hood.
And we forget the mechanics, don't we? We just see the magic. But LLMs, they work by predicting the next word. It's based on, what, a probabilistic average?
A probabilistic average of billions, maybe trillions of data points. It's basically the statistical summary of everything humanity has ever written.
So it's mastered the average of what we sound like.
Precisely. It can write a beautiful essay on Shakespeare or explain string theory perfectly, but it hasn't actually understood any of it. It's just mimicking the patterns in the text it was trained on.
He had that great analogy, didn't he? That AI is basically a super powerful parrot.
Yes. And that parrot can discuss quantum mechanics, but, and this is the key, it will never be the Einstein who discovers E equals mc squared.
Right.
It's just synthesizing what's already there. It's not creating a truly new paradigm because it's missing something fundamental to how the universe itself works.
Okay, but hold on. If it's combining human thought faster than any human ever could, doesn't that recombination become something new? Isn't that how we make discoveries anyway? By standing on the shoulders of giants?
That is the critical question.
Yeah.
And Wolfram's answer is no, because he argues that LLMs lack something he calls computational irreducibility.
Okay.
And we got to slow down here because this concept is like key to his entire worldview.
Computational irreducibility. That sounds like a grad school seminar. Break it down for me.
Okay, think of it like this. If you can solve a problem with a simple formula, a shortcut, it's computationally reducible.
Like, figuring out where a baseball will land. You don't have to simulate every inch of its flight.
Exactly. You use the formula, you jump to the end, but some processes have no shortcuts. You have to run every single step to know the outcome. That's computationally irreducible.
And what's an example of that?
Well, the classic one is predicting the weather a month from now. You have to run all the equations in order. Or a cellular automaton like Rule 30.
Oh, Rule 30, right. The little black and white pattern that creates this insane complexity from just one simple rule.
That's the one. You can't write a formula to predict what the 10,000th line will look like without computing all 9,999 lines before it. You have to run the program.
You have to do the work. No skipping ahead.
And Wolfram's big idea is that the universe is one of these irreducible computations.
Yeah.
It's doing the work, step by step. AI, on the other hand, excels at pattern recognition, which is a kind of shortcut. It's missing that deep computational reality.
So AI is basically copying the homework while the universe is like doing the math in real time, second by second. But okay, if AI is just a shortcut machine, then what is its actual value to us?
Well, if we look past the hype, its real value is as a kind of. Great translator. A while back, there was this deep analysis in the journal Nature that said AI's true strength is cross-disciplinary knowledge aggregation.
Cross-disciplinary knowledge aggregation. I love the jargon. What does that actually look like?
It's actually incredible. So imagine a biology paper from the 1970s on cell membranes. Now imagine a material science paper from the 2020s on ceramic crystallization.
Totally different fields, different language, different math.
Right. They'd never talk to each other. It's like reproductive isolation between sciences. But an AI can scan both and instantly find the hidden mathematical similarities between them. It just breaks down the walls.
So it's not creating new knowledge from scratch, but it's making new connections between existing knowledge, which for us is kind of the same thing. It's the ultimate librarian.
It saves us decades of work. And this leads us to a really important idea, the scarcity principle. So if AI makes the how, the execution, the writing, the coding basically free,
right,
what's left that's expensive? What's the last human fortress?
Creativity, imagination.
Wolfram gives, I think, a more profound answer. He says it's what to do, purpose. In the 2026 AI era, the most valuable things will be curiosity and, this might sound weird, pain and suffering.
Wait, suffering. How is suffering an asset? That sounds more spiritual than computational.
It's about the drive. An AI isn't going to stay up all night, fueled by angst and coffee, because it has this burning need to solve some cosmic mystery. It doesn't suffer from not knowing.
It just runs its program until the battery dies.
Exactly. That desire to push through pain for a breakthrough, that's a purely biological human thing. It's tied to our emotions, our survival.
That makes so much sense. You need the desire for the breakthrough. I saw a New York Times piece that said something similar. AI frees us from being the craftsmen so we can become the architects.
Perfect analogy. We don't lay the bricks, we design the building. But, and this is the big but, what happens when the architect's vision is mediocre, but the tools are like nuclear level powerful?
And now we're in the real world. This is where AI becomes a magnifying glass for, well, aesthetic poverty. I've been seeing this all over social media, especially on platforms like Xiaohongshu and Weibo.
All the posters.
The posters, they're so high res, so oversaturated, and they all have this AI flavor.
It's that classic collision of technology dividend and aesthetic poverty.
Yeah.
The tool is incredible, but the human giving the prompt has no vision. So if your spell is just mediocre.
You get mediocrity squared.
And it looks like plastic, glossy, hyper-detailed plastic. If you don't understand composition or light or weight, the AI won't fix that for you. It just executes your bad ideas perfectly.
It's a mirror for your own lack of deep knowledge.
And a lot of it comes from everyone using the same lazy prompts, right? Atmospheric, grand, stunning, high definition.
Yeah.
The algorithm just spits out the statistical average of stunning.
This has some really serious real-world consequences, too, especially when we look at, say, some of the propaganda case studies that have been circulating. These AI-generated military posters that are supposed to look strong and be a deterrent.
But they often fail so spectacularly because just obvious logical flaws and really poor artistic choices.
I saw one where the warships were floating, like, way too high on the water, almost flying. And another was this weird hybrid of an aircraft carrier and a cargo ship. It just looked wrong.
And the critique I read was just brutal. It was something like they're using nuclear-level tools like Midjourney to make something that looks like a cheap 90s sticker.
Yeah.
The Financial Times called it out, too. That plastic feel and lack of detail, it just exposes the creator's aesthetic barrenness. So instead of deterrence, you get mockery. They've even been nicknamed digital boxers.
And this feeds right into this bigger global issue of cognitive defense, you know, trust erosion. Reports are showing AI being used everywhere as a core tool for cognitive warfare.
But it's a paradox because when state media gets caught using AI-forged footage for what some call digital chest pumping, and those images have these huge, obvious errors, like showing planes that don't exist or are clearly copied from U.S. designs.
It creates a massive trust crisis.
A huge one. The tool completely backfires. It undermines the very authority it was trying to project.
Which is why things like that high school AI art controversy back in 2024 are actually really important.
They're a necessary shock to the system. It's like a weakened vaccine. It forces all of us to develop our own aesthetic and logical immunity to what's fake.
We're building cognitive antibodies. Okay, let's pivot. Let's scale way up. If AI isn't our enemy and it isn't our friend, what is its existential role in all of this?
We have to think about it on a cosmic scale. Wolfram suggests AI might be a kind of digital organ, or maybe even a silicon-based virus, that the universe itself grew to reshape our minds.
A silicon virus that forces an upgrade to our carbon-based operating system. This is that principle of computational equivalence, right?
Exactly. Wolfram's point is that there's no real hierarchy. A flowing cloud, your brain, ChatGPT, they're all computationally equivalent. They're just running the cosmic program at different speeds and on different hardware.
So we're not special, we're just slow.
We're just slow.
Yeah.
But that brings us back to purpose. The universe has been running for billions of years without wanting to go anywhere. It's just running.
But humans, with our short little lives, we need shortcuts. Yeah. We need purpose because we don't have forever.
And that's the punchline. AI possesses infinite answers, but only humanity possesses the questions. AI is the accelerated observer. The cosmos delivered to us. It frees us from the tedious how, so we can finally focus all our energy on the fundamental why.
Okay, so if the universe is a program, and Wolfram's physics project says it's built on this hypergraph of simple rules, can we find a backdoor? Can we use AI to cheat the system?
In theory, yes, absolutely. Wolfram says we're looking for a computational shortcut. Right now, we only see the big picture, the statistical results, which we call the laws of physics. Hacking it means getting to the underlying rules.
So what are the theoretical shortcuts? I think you said there were 3. The first one is a spatial short circuit.
Right. This is when 2 points in the network, say on opposite sides of the galaxy, establish a direct link. They bypass all the space in between. What does that sound like to you?
Quantum entanglement. Instant connection, faster than light.
Precisely. In computer terms, it's a jump instruction. It's a command that tells the program to skip a billion steps and go straight to the destination.
That's amazing. Okay, shortcut number 2. Changing the observer.
The flow of time depends on the observer. We know this from relativity. So if we could change our own computational pace, our brains or our AIs, to match the universe's refresh rate,
we'd get elevated program access. We could see the code as it's running, maybe even see time stop or go backwards.
We'd be matching the speed of the processor. And the third shortcut is exploiting local pockets.
This one sounds a little more down to earth.
It is. It's what we already do. The universe is mostly irreducible, but there are pockets of computational reducibility. These are the places where we have symmetry, conservation laws, predictability.
So when we build a satellite or a plane?
We're just exploiting those known program vulnerabilities. We're using the bits of the code where formulas do work.
This is so deep. But it feels like we have the administrator problem. We're characters inside the program. We can't reach outside and move the mouse.
We're the Sims, and we can't rewrite the source code unless and until an AI evolves to a point where its computational power can actually reverse engineer the entire hypergraph.
So the goal isn't to beat AI, it's to use it. Use it as our tool, our accelerated observer, to finally touch that source code. Use it to answer the simple questions, like Rule 30, that unlock everything else.
The 2026 era isn't the AI era. It's the year humanity finally has enough power to start learning the language of the cosmos.
Wow, my brain is buzzing. My entire perspective on my own existence feels a little different now. If we paint Rule 30 on the studio wall, do you think we'll evolve into superhumans?
I think you'll evolve into a slightly faster, more caffeine-dependent version of yourself.
Darn it. I was really hoping for administrator privileges. Well, whether you are ready for faster computation or just ready for dinner, thank you for joining us for this Sip and Talk.
We covered a lot today, from bad propaganda posters to the deep physics of reality. Our goal is always just to put these ideas out there objectively and hopefully get you to keep asking those big human questions.
Absolutely. Please make sure you subscribe to the show and go check out our old friend Mickey's YouTube channel, Mickey to Life. He's got some great memes and travel vlogs.
We'll catch you next time.